which will return the real credit card number to you when you need it and only when you need it. That means if your systems get hacked or if you want to move them into the public cloud, if somebody steals that data, all they're stealing is a token. The token is absolutely no use to them. If they presented that token to any kind of authorization system, they would be rejected on that basis. So this way you can take data that previously was too risky to move into a public arena and actually store that data out there. The next point is looking at teleportation technology. Now, I'm not sure how many people are here familiar with teleportation technology, so I'll go into that in a bit more detail a bit later. But the idea here is that you can take your processing workload and move it into the cloud without sending the data and without making the data available over the WAN. So you can still have that processing going on in the cloud. The next point here is to, once you've actually moved your data into the cloud, you need to make sure there are controls in place or automated systems to check for data loss. Data loss prevention, do a search for this. There are lots of different options out there, but the key thing is it works with email, it works with SharePoint, file systems, network sniffing, and you can train it to look for individual tags or regular expressions or usernames, passwords, perhaps the name of the company you're about to buy, perhaps the name of somebody you're about to hire. Whatever is sensitive information to you, you can train it to look for that, and it'll either flag up saying somebody in your organization is transmitting this data, or it'll actually flag it and prevent the communication. So, let's go straight into myth 4 to talk a bit more about teleportation. The idea here is that you can take a running workload from your private cloud and move it into the public cloud. And this really is the great aspect of cloud computing, because you can use this elastic nature to scale up. So let's say, for example, you're building a web order processing system. If you've got a huge promotional campaign which suddenly takes effect and you haven't got enough processing power, then a good thing to do would be to spawn up more instances in the private cloud to deal with that. But the problem is, if that's running on, let's say, something like VMware, it's actually quite difficult to take a server whilst it's running and move that to a completely different network, or hundreds of miles away, or perhaps move it to a different country, or move it into your service provider's cloud. That's quite a difficult thing to do. And even if you did do that, imagine if that VM's got 100 gig of data associated with it. By the time you've copied 100 gig of data up to your service provider, it might be time to have that VM back in-house. So that's a difficult challenge. So one option for looking at this is the concept of a distributed data cache. And all you do is, instead of copying all the data to the private cloud, you just take just enough data that you need to act as a cache for that virtual machine and synchronize that across the different locations that you want to operate your services in. So in this case here, in this example, we've got the VM which is running in Frankfurt, and we can move it to London whilst it's still running with no downtime, and still leave the data in Frankfurt. And optionally, if you want to, you can copy that data in the background and the VM will keep running. Second option here, and this is the only option on all the slides which I'm going to tell you about, which is not actually in the GA products at the moment. This is not in VMware, but it's being demonstrated in VMware and EMC's labs. Is this scenario where a customer came to us and said, we've got a big grid of high-performance computing, and sometimes we have a job, and the job runs like for 4 days. And it's a very important job that we need to know the answer to this particular simulation. And then all of a sudden, someone will come along and say, I've got another job which is way more important, and it needs to be processed immediately. Now, they don't want to stop job number 1 because they'd lose 4 days' worth of processing. So what they can do in this environment is, across their cluster of 50 virtual machines, have them all communicate, take a synchronous checkpoint, and then move that checkpoint into a public cloud without stopping the processing, and have that job number 1 move in its entirety into the public cloud. That frees up their private cloud so that they can then process the critical job which executes quickly on their own private cloud. Now, if you want more information about how this works, it's a distributed cache technology, as I was saying. Come and find me afterwards, and I'll go through that in a bit more detail. So, in summary, you can use this technology for virtual machines. You could use it to spread your Oracle rack around the place. It doesn't need a particular type of storage or a particular type of virtualization. But the key takeaway for this is you don't always need to move all of your sensitive data into the public cloud. The other key point about this is if you decide at the beginning that when you architect your private cloud solution that it's going to use the similar technology that the service providers are already using, then you've already enabled your journey into the hybrid cloud. Because you can guarantee that if you're using a particular approach to virtualization or storage and you decide to use a public cloud solution from CSC or Orange or T-Systems, that compatibility is already there. So, that myth, I'd say, is busted. Finally, myth number 5, my apps won't run locally and in the public cloud. So, why would you want to do that anyway? And the idea is if there's some problem with your public cloud supplier, you want to be able to take that application back. Okay, you don't want to have it lost or locked or inaccessible. If I move my apps to the cloud and service provider fails, have I lost everything? Well, not if you can take it back. So you need to take the usual approach to risk management, identifying which risks are going to have the biggest impact and likelihood. Now, there are lots of different approaches to this. The one approach I'm going to talk about today is using the Spring Source model. Now, Spring Source as a framework allows you to build native Java applications and host them in the cloud. You don't need to run them on a VM. You could have them running in your internal systems one day, and then the next day push them out to the Google Cloud. That would be a typical use case. The difficulty about that is, imagine building this application. Let's say we want to go back to the original example, which is a web ordering system, which runs in the public cloud, and an order fulfillment system that runs in the private cloud. If you're going to build that environment, you don't know whether the component you're building is going to be running in the private cloud or the public cloud at any one time. So how do you code it so that it's completely aware and it understands the security constraints, it understands the different databases that it needs to connect to? Well, one option is this Spring Source framework. And I'm not going to go into all of the detail here. Just there's 2 things I want you to take away from this. The first one is that when you build your solution using this Java framework, your dependencies are determined at runtime. So to give you a real-world example, if you're running in the Google Cloud, your data source is going to be MySQL. If you're going to be running in-house, you might say, I'm going to have the application automatically connect to Oracle. So this is a much simplified approach. We can also create a single proxy to wrap around your methods. So let's say the idea is you want to get customer data. At that point, the proxy kicks in and says, hey, I know that you're running in the cloud, and therefore, before you get access to any customer data, I'm going to do a different type of security authorization check. And because that's been configured into the framework, the application is automatically aware of the cloud environment that it's running in, which means that when you're testing your application, you only need to test the functionality which is specific to your line of business application. You can forget about the fact that it's running in a public cloud or in a private cloud. And it's a much more secure and controlled approach. So who's doing this? Well, here's one big example. And of course, I'm not suggesting that Barrett himself is coding lines of Java and uploading it to Google. But these kind of applications are in use, and there's been some great successes using that approach. So, myth number 5, myth busted. In summary, there are some valid real-world concerns, I think, about security, but there are ways to mitigate it. So how do you mitigate it? Well, step 1, first of all, I'd say choose a partner who can demonstrate that they've got the capability in the real world to actually implement your vision of the cloud, and ask them about how do I get to a hybrid cloud solution. Ask them what you're actually going to get. So you need to start looking at the economic view first, and then on top of that, lay on the security side. And once you've got those filters in place, you can finally make your decision about which parts of your environment are ready to go to private or public cloud. Another typical output would be a heat map, so you can start to see which of your applications are most suitable to do that. So that would be step 1. Step 2, carry out a discovery. You need to have an automated view, and it has to be automated. You can't have people walking around with clipboards, for example, or relying on people to update CMDB. Have an automated view of what you've got right now so that you can work out what's appropriate to go into the cloud. Once it's in the cloud, it's going to be jumping around between different places anyway, so that system has to be automated. What do you get from that? The business case you get needs to have real figures for what you can save from an IT spend point of view. In this particular case, I've taken the figures off, but this number up here should be able to tell you exactly what you're going to get over the 2-year basis. Finally, future-proof your architecture. Look at what the service providers are doing and see what commonality you've got with your service providers and the systems that you're architecting. And be open to new ways of thinking and investigate some of these new concepts that I talked about today. And as I say, if you want any more information, then we can talk afterwards. There's some links that I put in here to do further research, and you can do some more reading to see what KPMG thinks about this, because this is exactly the thing that they're doing in their organisation. This was taken from last Tuesday, I think. And that's it from me. Thank you very much.